Okay, so today we are going to discuss regarding the problems. Okay, problems regarding molarity. Already parts per million we have calculated, so ppm, and also the mole fraction. So one thing you have should note that mole fraction is nothing but symbol we have given. So it's like x. It is nothing but chi. ಏನು ಹೇಳ್ತೀವಿ ನಾವು ಅದನ್ನು chi ಅಂತ ಹೇಳ್ತೀವಿ, right? So x ತರ ಇದೆ, but it is not x. It is nothing but the Greek letter. So it is like. So we are writing like x, but it is not x. Just remember. So this is we are calling chi. Okay, so remember that. So it is chi. Okay, so now we will go for the first problem regarding molarity, right? So here they have given to calculate the molarity of a solution containing 5 grams of sodium hydroxide, 5 grams of sodium hydroxide in 450 ml of solution, right? So standard solution we are calling. So we are preparing that standard solution in standard flask, right? Standard flask. Okay, so they have prepared, right? So they have prepared the 450 ml of what solution, 450 ml of solution. So they have added how many? 5 grams of solute, that is nothing but sodium hydroxide. For the 450 ml of solution they are adding 5 grams of sodium hydroxide, right? 5 grams of sodium hydroxide and add ಮಾಡಿದ್ದಾರೆ, 450 ml solution ಅನ್ನು ಮಾಡಿದ್ದಾರೆ, and they asked what is the molarity of this solution, what is the molarity of this solution, right? So that solution consists what 5 grams of sodium hydroxide. We have to find out the molarity of this solution. So what is the molarity of solution? We should know the formula, right? So already we have the formula, so direct formula we can write, right? So what is direct formula? So molarity is nothing but molarity is equal to what? So weight, right? So weight of the solute into 1000, right? So 1000, so that is in, they have given ml here, so hence we have to convert it into what? Liter. Hence we are dividing 1000 for it, and then later we have this formula. Okay, and then molecular mass of solute into what you have, volume in ml. So volume in ml. Okay, the solution volume in ml, right? So what is the weight? They have given 5 grams. Okay, 5 grams into 1000 divided by molecular mass of sodium hydroxide we have to find out. Okay, NaOH. What is the molecular mass, right? So here sodium, what? So sodium is nothing but nearly 23, right? 23 plus oxygen you have what? 16 atomic mass, right? And then hydrogen 1. So totally what happens here? Totally you are getting 16, 3, 19 plus 1, 20, 20. So there is 40 gram per mole. This is the molecular mass, right? Hence the molecular mass we have found it, right? So that is nothing but 40 gram per mole into what happens? Volume in ml. We have that how many? 450. What is that? 450 ml, right? So cancel 0 here, 1 1 2 2. Okay, 5 ones are 5 nines are, right? So in denominator you have what? 4 into 9. Numerator you have 10. So 10, 4 into 9. Simplified. Finally you are getting answer nearly what? 0.278 mole per liter. So mole per liter. So this is the molarity of that solution. Okay, so you must know that important problem, right? So molarity, weight into 1000 divided by molecular mass into volume of that is in ml. They are already given here. Weight, what is the weight of solid? Is nothing but 5 grams into 1000 divided by 40 grams. So it is nothing but molecular mass and I find out ಮಾಡ್ತೀರಿ. Sodium 23 atomic mass plus oxygen ಎಷ್ಟಾಗುತ್ತೆ 16, and then hydrogen is 1 and plus 1 we have to, right? So at the end what you are getting here, so that is 40 gram per mole. Just substitute that value here. Okay, and then 450 ml they have given. Simplify. Finally we are getting what? 0.278 mole per liter. So that is the molarity of that particular solution. Okay, so the same way we are going forward. The second problem, calculate the molality, right? So here we have what? Molarity is different and molality is different. So molality of 2.5 gram, right, 2.5 gram of ethanoic acid is nothing but CH3COOH in 75 grams of the benzene. Yado 75 grams of benzene alli kottidare. So weight of what solute they have given, weight of solute ethanoic acid, or else you can say it is CH3COOH, right. It is nothing but 2.5 gram, right. And then mass of the solvent also they have given, mass of the solvent, it is nothing but 75 gram, right. So we know that the formula, right. So formula of the molality, formula of molality is equal to weight of solute into, so they have given gram, hence we have to convert it into 1000 kg, hence we have to multiply here in that formula, that is 1000. So in denominator, so we are dividing that value, so it will come for the numerator. You know that divide by molecular mass of that solute, and then weight of the solvent, or else mass of solvent, right. So weight of the solute we know that 2.5 gram into 1000 divide by the molecular mass. So molecular mass of the ethanoic acid we can find out, right. So here we can find it out, right. So molecular mass of ethanoic acid CH3COOH, we can find out carbon here. How many carbons are there? 2 carbons are there, and 2 oxygens are there, and 4 hydrogens are there, right. Carbon we know that, so I can write here also once again 2 carbons, okay, and then 2 oxygens, and then 4 hydrogen, right. So I can write like this also, C2 O2 or H4, or else you can write any way C2 H4 O2, anything if you want you can rewrite it, okay. So now we can calculate the molecular mass of that acetic acid or else ethanoic acid. Carbon we know that, so what is the atomic mass of carbon? That is 12. How many atoms are there? 2 plus hydrogen is 1. How many atoms are there? 4 plus oxygen 16 into 2, right. So 24 plus 4 plus 32. So what is the answer you are getting? 36, 4, how many? 36 or 4, so that is totally we are getting 60, right. So 60 you are getting, so 60 gram per mole, 60 grams per mole, right. Substitute that value, 60 gram per mole into weight of the solvent is nothing but what? 75 gram. So finally solve this, right. So that is 0.556 mole, so it will come upside mole, and gram is converted into kg per kg, right. So per kg you are getting, okay, kilogram per kg. So this is regarding what? So molality, okay. So molality, this is molarity, mole per liter, okay, mole per liter, mole per kg. So that is the difference between molality and the molarity with the problem, okay. So one more point you should note here, so very important, so they will ask in examination, right. So whatever the things I have written here, mass percentage and the ppm regarding that mass percentage, and the mole fraction and the molality. So if you see any formula, so you are getting like this, mass percentage is nothing but W by W, weight by weight. So ppm also we know that, right, and then mole fraction also we know that. So if you multiply here 10 to the power of -6, you are getting what? Not -6, so that is what? 6. So that is what we are calling parts per million. 6, 10 to the power of 6 we are calling what? Parts per million. So mass percentage, that may be in parts per million, and the mole fraction and the molality. So molality. So these all are what? So they all are so independent on temperature. Very very important. Independent on temperature, right? Because mass, these all things are based on what? Mass by m by m, mass by so m by m, right? Or else you can say it is weight by weight, you can say, right? Weight W by W percentage, right? If you multiply 10 to the power of 6 is nothing but parts per million, mole fraction, and the molality. So molality, it is dependent upon the kg, right? So that is mass. Hence mass is independent on the temperature, and whatever the values you are getting here, mass percentage, ppm, mole fraction, and the molality, very very important, molality. So it is nothing but small m, molality. So these values are independent on the temperature. And if I come for the volume, so volume by mass by volume, that is W by so here you have volume means V by V, so V by V, and mass volume M by V, mass volume. If you multiply it by 10 to the power of 6, they are in the parts per million, this solution. And also the molarity is nothing but solution, so volume, so we are having volume, right? So all the volume concept here, volume percentage. So hence if you take a particular liquid or else water in a beaker, just if you heat it, right, vary the temperature, so then what happens, it will evaporate. Avaga enagutte namage volume ennodu change agutte. So yavaga volume change agutte, avaga volume percentage, what is the calculation? So in different temperature, the answer you are getting what? So different values. Hence we are calling, so these values, whatever the volume percentage, mass volume percentage, and the molarity, they are depending upon the temperature. Hence you can say it is temperature dependent. Temperature dependent. So temperature dependent, you can say it is temperature dependent. Hence why? Because volume of solution or solvent, anything, it is depending upon what? Temperature. So very very important, so note down these things. Okay, so very very important. So independent, so independent on temperature, so that is dependent on the temperature. Okay, so next we will go for the very very important, so that is solubility, right? So what is solubility, what is the saturated solution, and what is unsaturated solution, right? So before going to that, we will go for solubility, the general definition for the solubility, and then we have to go for what? Solubility of solid in liquid, and then we have to move for the solubility of gas in liquid. First we will go for what exactly solubility, right? So what is solubility? So simply we can take a particular solvent, right? So take a beaker with water, right? So take a beaker with water, right? So water, you have water. So for that you can add salt for it, sodium chloride. So when you add sodium chloride, NaCl for it, right, and stir it very well. So then what happens, the more and more solute get soluble, or else that process we are calling dissolution. Sodium chloride hakidaga enagutte, so they will disappear, right? So when you add sodium chloride, stir it, and there disappears. Where they are going? So where it is present, sodium chloride, it means sodium chloride is dissolved in where? In water. So water enagutte, sodium chloride disappear agutte. It is nothing but what? So you can say it is the sodium chloride undergone soluble, where? So in water. Hence we are calling this process, we are calling what? Solubility, right? Solubility. What is solubility? Solubility is nothing but, so you can add more and more sodium chloride and then stir it, the solubility increases, that is we are calling dissolution. Dissolution anta heltivi, and that is what we are calling dissolution. From the dissolution you are getting what? Sodium chloride plus water. So it is nothing but solute plus water act as solvent, and then what is you are getting? Solution, right? So solution. Finally what you are getting here? Solution, right? Now what is the solubility? Solubility is nothing but the maximum amount of substance that can be dissolved in a specified amount of solvent in a specified or else a specific temperature. So this is called what? Solubility. So ಏನು ಹೇಳ್ತೀವಿ ಕೇಳಿದ್ರೆ the specific amount of solvent we have to take, water. So when you add particular amount of solute for it and stir it, that process we are calling the solubility, and that is what exactly the solubility. Okay, so here if you take sodium chloride and sugar, sodium chloride and the sugar, so it is dissolved in water. So for the water, if you add that both sodium chloride and the glucose or else sugar, so the solubility or else it is undergo dissolution, they dissolved in water, right? So it is an example for what? Solubility of solid in liquid. ಏನಾಗುತ್ತೆ ಅದು? Solubility of solid in liquid. Solid ಎನ್ನುವಂಥದ್ದು liquid ಅಲ್ಲಿ ಯಾವ ರೀತಿ soluble ಆಗುತ್ತೆ, right? So it is nothing but solubility, right? Solubility, specific amount of what solvent we have to take and add the solute for it, and it is soluble, and is that process we are calling at particular temperature, specified temperature, we are calling solubility, right? Example you can take sodium chloride and the sugar which is dissolved in water, 1 point, and then you can add the naphthalene. So naphthalene and the anthracene for benzene, not water. Okay, for benzene, right? Two example I have given here. Number one is sodium chloride and sugar is dissolved in where? In water, but naphthalene and anthracene dissolved in benzene, right? So now we can try to dissolve what? Naphthalene and anthracene where? In water, right? So just see here, naphthalene and anthracene, is it dissolved in water? The question number one. And then sodium chloride and sugar, whether they are dissolved in benzene, right? The cross word I have given there, right? Cross mark we have added, right? So here sodium chloride and sugar, add for the benzene, whether they undergo soluble, right? Or else naphthalene and anthracene, dissolve it in water instead of sodium chloride, right? So add what? Naphthalene here, naphthalene plus, or else you can add anthracene, so anything. So anthracene or the naphthalene, where is dissolved? No, right? So ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಮತ್ತು ಶುಗರನ್ನು ವಾಟ್ರಲ್ಲೇ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ, ನ್ಯಾಫ್ಥಲಿನ್ ಮತ್ತು ಆಂಥ್ರಸೀನು ಬೆಂಜಿನಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಅದೇ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಶುಗರನ್ನು ಬೆಂಜಿನಿಗೆ ಹಾಕಿದರೆ ಸಾಲ್ಯುಬಲ್ ಆಗಲ್ಲ. ಅದೇ ರೀತಿಯಲ್ಲಿ ನ್ಯಾಫ್ಥಲಿನ್ ಮತ್ತು ಆಂಥ್ರಸಿನನ್ನು ತಗೊಂಡು ನೀರಿಗೆ ಹಾಕಿದರೆ, ವಾಟರಿಗೆ ಹಾಕಿದರೆ ಡಿಸಾಲ್ವ್ ಆಗಲ್ಲ. ಸೊ ವೈ? ಸೊ ದಟ್ ಇಸ್ ಅ ಕ್ವಶನ್ ಮಾರ್ಕ್. ಸೊ ವೈ opposite doesn't take place, right? Hence generally we are calling the sodium chloride is nothing but what? Polar, right? So polar solute you can say. Therefore polar solute only dissolve where water is nothing but what? Polar solvent, right? Polar solvent. Sodium chloride is polar, Cl minus. Water is what? H2O. So this is delta. So here delta plus and oxygen delta negative. So polar solvent water, right? So here polar solid, example NaCl, and then the polar solvent, it is nothing but what? H2O, right? So polar solute can dissolve, polar solute dissolved in polar solvent, and the same way what happens? Non-polar solute dissolved in, or else dissolves in non-polar solvent. So remember, very very important, right? So polar solvent ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? polar solute dissolve ಆಗುತ್ತೆ. ಅದೇ ರೀತಿಯಲ್ಲಿ non-polar solute ಯಾವುದರಲ್ಲಿ dissolve ಆಗುತ್ತೆ? non-polar solvent ಅಲ್ಲಿ dissolves ಆಗುತ್ತೆ, right? ಆದ್ದರಿಂದ polar solute and polar solvent, non-polar solute and the non-polar solvent. Hence so generally we can say what? The solubility of solid in liquid. So generally you can say very very important, like dissolves like. So this is the principle of what? The solubility of the solid in liquid. Like dissolves like, very very important. So why like dissolves like? Polar solute dissolved in polar solvent and non-polar solute dissolved only in non-polar solvent. Hence this kind of things we are calling like dissolves like. In this principle what happens? The solubility of solid in liquid may takes place. Okay, so liquid may takes place, right? So one more thing, so you can see here, so when you add sodium chloride for water, right, NaCl for water, right, NaCl for water, solute plus solvent, what happens, you are getting solution, and that process what we are calling dissolution. ಏನು ಹೇಳ್ತೀವಿ ನಾವು ಅದನ್ನು ಡಿಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗಾದರೆ ಡಿಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೇನು? ವೆನ್ ಎ ಸಾಲಿಡ್ ಸಾಲ್ಯೂಟ್ ಆಡೆಡ್ ಟು ದಿ ಸಾಲ್ವೆಂಟ್, some solute dissolves and its concentration increase in the solution, this process is called as the dissolution, right? So solubility is different and the dissolution. Solubility means they are undergo dissolved the specific amount, and that is the fact we are calling solubility. But this process we are calling what? The process we are calling dissolution ಅಂತ ಹೇಳ್ತೀವಿ, ರೈಟ್. ಸೊ 1 teaspoon sodium chloride ಹಾಕಿದ್ರಿ, ಸ್ಟರ್ ಮಾಡಿದ್ರಿ, and what about the concentration? Once again you can add one more teaspoon of sodium chloride, dissolve it. So more and more sodium chloride if you goes on dissolve here, and then what about the concentration? Concentration already we have learned concentration. So if the dissolution is increases, the concentration becomes what? More and more. The concentration becomes more and more, right? So now I am adding one more teaspoon here, right? Right, 1 teaspoon, right? So 1 teaspoon I am adding here, right? Add what? 5 grams of sodium chloride for it. Stir it, and once again you can add one more 5 grams of it. Stir it, right? So you can add more and more solute for particular solvent or the solution, you can say. Already solution ಮಾಡಿ ಇಟ್ಟಿದ್ದೀರಿ, ಇನ್ನೂ ಅದಕ್ಕೆ solute ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ ಅದೇನಾಗುತ್ತೆ, ಇನ್ನೂ soluble ಆಗುತ್ತೆ. Such a solution we are calling what? Unsaturated, right? Unsaturated solution, right? You can add more and more solute for a solution or else a solvent, and such a solution we are calling unsaturated. Saturated ಆಗಲಿಲ್ಲ, unsaturated. And then you have one more thing is saturated solution. Saturated. So ಇವಾಗ ಏನಾಗ್ತದೆ, ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಹಾಕಿದ್ರಿ, ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ರಿ. So 5 grams one more, add it, dissolve it. So once again you can add, dissolve it, and when you add one more time, so then dissolution doesn't take place. ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ, ಡಿಸೊಲ್ಯೂಷನ್ ಎನ್ನುವಂಥದ್ದು ಆಗಲ್ಲ. ಆವಾಗ ಏನು ಹೇಳ್ತೀವಿ, ಆ್ಯಂಡ್ ನೋ ಮೋರ್ ಸಾಲ್ಯೂಟ್ ಯು ಕ್ಯಾನ್ ಆ್ಯಡ್ ಫಾರ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್, ಆ್ಯಂಡ್ ದ್ಯಾಟ್ ಸೊಲ್ಯೂಷನ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್, ಆರ್ ಎಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಸೇ ಇಟ್ ಈಸ್ ಸ್ಯಾಚುರೇಟೆಡ್, more concentrated or else saturated. Two types you have, one is saturated and one is unsaturated. Okay, so note it down. What is the saturated solution? Saturated solution in which no more solute can be dissolved at the same temperature is called the saturated solution. Okay, so note it down. What is saturated solution? A solution in which no more solute can be dissolved at the same temperature and pressure is called the saturated solution. And what about the unsaturated solution? A solution in which some more solute you can dissolve under the same temperature and the pressure is called as the unsaturated unsaturated solution. Okay, so very important, saturated solution and the unsaturated solution. So principle anna keltare illi, like dissolves like. What is this principle? So what is here? Polar solute dissolved in polar solvent and non-polar solute dissolved in non-polar solvent, right? So polar alli enagutte namge, so dipole irutte, so there is an interaction, or else you can say hydrogen bonding. Alli hydrogen bonding ಆದರೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ಡಿಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ, ರೈಟ್? ದರ್ ಇಸ್ ಅ ಪಾಸಿಬಲ್ ವಾಟರಿಗೆ ಮತ್ತು ಇನ್ನೊಂದು ಯಾವುದಕ್ಕೂ ಏನು ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆದರೂ ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಪೋಲಾರ್ ಆಗಬೇಕಂತಿಲ್ಲ. ಸೊ ಬಟ್ ದಟ್ ಶುಡ್ ಬಿ, ಸೊ ಅಫ್ಕೋರ್ಸ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಪೋಲಾರಿಟಿ ದಟ್ ಶುಡ್ ಬಿ ಇಂಡ್ಯೂಸ್ಡ್, ರೈಟ್? ಸೊ ಇಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಎಲಿಮೆಂಟ್ ಅನ್ನುವಂಥದ್ದು ಇರುತ್ತೆ, ಆಕ್ಸಿಜನ್, ನೈಟ್ರೋಜನ್ ಆರ್ ಫ್ಲೋರಿನ್, ಓಕೆ, ವಿಚ್ ಈಸ್ react with the water, so that is dissolved. So dissolution you can observe. So this is regarding what? The solubility and the solubility of a solid in a liquid. So next we will go for the effect of temperature, right? So what is the effect of temperature on the solubility or else dissolution process, right? So ಏನು ಮಾಡ್ತೀರಿ ಕೇಳಿದ್ರೆ, ಸಾಲಿಬಿಲಿಟಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಿದ್ರೆ ಏನು ಮಾಡಬೇಕು ನಾವು? ಎಟ್ ದ ಎಂಡ್ ಸ್ಯಾಚುರೇಟೆಡ್, ರೈಟ್? ಶುಗರ್ ಸಿರಪ್ ಮಾಡ್ತೀರಿ, ರೈಟ್? ಶುಗರ್, ವೆನ್ ಯು ಪ್ರಿಪೇರ್ sugar solution or else syrup of sugar, you have to boil it. So ಯಾಕೆ ಬಾಯ್ಲ್ ಮಾಡ್ತೀರಿ? So you can add, after increasing the temperature, what happens, more and more sugar or else solute you can add for it. ಏನಾಗುತ್ತೆ ನಮಗೆ ಅಲ್ಲಿ it is depend, so whether it is exothermic or endothermic, right? So first we will go for the effect of temperature. Effect of temperature, right? So effect of temperature. Okay, so nearly saturated solution, right? So I will draw it diagram once again. All right, so if I take saturated solution, for a saturated solution, for a saturated, right, solution is what? Saturated solution. What is for a saturated solution? No more solute you can add at that particular pressure and the temperature. Such solution we are calling saturated. You are not going to add more and more salt. Why? It doesn't dissolve, right? So during this type of system, means saturated solution, this system is what? Exothermic, or else we can say it is endothermic we are calling, not exothermic, endothermic. So during the saturated solution, at the point of saturation, and the system or its dissolution becomes what? Endothermic. So endothermic means, so it requires what? Temperature, right? So it will absorb heat. So that is endothermic. Endo means it is absorbs heat, right? So it tries to absorb heat for the dissolution, right? So now suppose the solubility, or else you can dissolution process, I will write dissolution, it may be exothermic or the endothermic, eradu agutte, so it is depend, right? Dissolution process may be what? Endothermic or exothermic, right? So endothermic, which is absorb heat, right? So endothermic andrenu? Absorbs heat. See here clearly. So heat annu ಏನು ಮಾಡಿದೆ? System absorb ಮಾಡ್ಕೊಂಡಿದೆ, right? System absorb ಮಾಡ್ಕೊಂಡಿದೆ. So then you can add what? More and more solid. Dissolution process ಏನಾಗುತ್ತೆ ಇವಾಗ? Increase ಆಗುತ್ತೆ. For a dissolution process, if it is endothermic, so dissolution will increase. When you can rise in temperature. So temperature na rise ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ? Dissolution process increase ಆಗುತ್ತೆ. So ಅದರಿಂದ ಏನು ಹೇಳ್ಬೋದು? Dissolution is nothing but endothermic. Endo means it is absorbing heat energy, right? It is absorbing the heat energy. Hence if you increase the temperature, ಇದನ್ನ ಬಿಸಿ ಮಾಡಿದ್ರೆ, if you increase the temperature, ಆವಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ? ಡಿಸೊಲ್ಯೂಷನ್ ಎನ್ನುವಂಥದ್ದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇವಾಗ ನಾನೊಂದು ಸಾಲ್ಯೂಟನ್ನು ಆ್ಯಡ್ ಮಾಡಿದ್ದೇನೆ, ರೈಟ್? ಇವಾಗ ಏನಾಗುತ್ತೆ ಕೇಳಿದ್ರೆ, ದ ಸಿಸ್ಟಮ್ or else the process of dissolution become what? Exothermic. Exothermic ಅಂದ್ರೇನು? ಸೊ ಬೀಕರನ್ನು ತಗೊಂಡಿದ್ದೀರಿ, ನಾನು ಯಾವುದೋ ಸಾಲ್ಯೂಟನ್ನು ಆ್ಯಡ್ ಮಾಡಿದ್ದೇನೆ, ಅದಕ್ಕೆ ಅವಾಗ ಸ್ಟರ್ ಮಾಡ್ತೀನಿ. ಇವಾಗ ಬೀಕರ್ ಎನ್ನುವಂಥದ್ದು ಏನಾಗಿದೆ? ಬಿಸಿ ಆಗಿದೆ. ಅಂದ್ರೇನು? ದ ಪ್ರಾಸೆಸ್ ಆಫ್ ಡಿಸೊಲ್ಯೂಷನ್ ಇಸ್ ವಾಟ್? ಎಕ್ಸೋಥರ್ಮಿಕ್. ಎಕ್ಸೋಥರ್ಮಿಕ್ ಆದರೆ ಏನಾಗುತ್ತೆ? ಎಂಡೋಥರ್ಮಿಕ್ಕಿಗೆ ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ ಆಗುತ್ತೆ. ಸೊ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಆದರೆ, if it is exothermic, the heat is released. ಹೀಟ್ ಎನ್ನುವಂಥದ್ದು ಏನಾಗಿದೆ? ಬೀಕರಿಂದ ರಿಲೀಸ್ ಆಗಿದೆ. ಇವಾಗ ಹೀಟ್ ಬೀಕರಿಂದ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಇಫ್ ಐ ರೈಸ್ ದ ಟೆಂಪರೇಚರ್, ರೈಟ್? ಆಲ್ರೆಡಿ ಏನಾಗಿದೆ? ಹೀಟ್ ಜಾಸ್ತಿ ಆಗಿದೆ, ಅದು ಬಿಟ್ಕೊಡ್ತಾ ಇದೆ. ಸೊ ಇನ್ನು ನೀವು ಟೆಂಪರೇಚರನ್ನು ರೈಸ್ ಮಾಡಿದರೆ ಏನಾಗುತ್ತೆ? ದ ಡಿಸೊಲ್ಯೂಷನ್ ಬಿಕಮ್ಸ್ ವಾಟ್? ದರ್ ಇಸ್ ನೋ ಡಿಸೊಲ್ಯೂಷನ್. ಹೆನ್ಸ್ ಇಫ್ ಯು ರೈಸ್ ದ ಟೆಂಪರೇಚರ್, ಫಾರ್ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಪ್ರಾಸೆಸ್, ಆವಾಗ ಏನಾಗುತ್ತೆ? ದ dissolution become what? Decreases. So dissolution will decreases after increasing the temperature. So which type of process? For exothermic process, not endothermic, for the exothermic process, right? First thing is saturated solution, nearly saturation, what happens, it becomes what, endothermic. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಎಂಡೋಥರ್ಮಿಕ್ ಈಗ ಆದಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ, ಸೊ ಹೀಟ್ ಇಸ್ ಅಬ್ಸಾರ್ಬ್ಡ್. ಸೊ ಸಪೋಸ್ ದ ಡಿಸಲ್ಯೂಷನ್ process is endothermic, if you rise the temperature, the dissolution become what, increases, right? Suppose the dissolution process is exothermic, so if you rise the temperature, then dissolution become decreases. So this is the what, the effect of temperature, effect of temperature where the solubility of solid in gas. Okay, so next, effect of pressure. Effect of pressure, effect of pressure. So if you put more and more pressure, whether it is dissolution becomes more and more, or faster the dissolution, no, right? So such solid and liquid, we know clearly, we know that there is no the impact of pressure, right? Solid ಅನ್ನು ತಗೊಂಡು ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ಏನಾದರೂ ವಾಲ್ಯೂಮ್ ಚೇಂಜ್ ಆಗ್ತದಾ, ಇಲ್ಲ. ಅದೇ ಲಿಕ್ವಿಡ್ ಅನ್ನು ತಗೊಂಡು ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ವಾಲ್ಯೂಮ್ ಏನಾದರೂ ಚೇಂಜ್ ಆಗುತ್ತಾ, ಇಲ್ಲ. ಸೊ ಅದರಿಂದ ಏನಾಗುತ್ತೆ ನಮಗೆ, the effect of pressure in solid and liquid, it is least affected. The pressure plays an important role where so it is in gas. So when you so take gas, right, so gas particles or else a gaseous solution, so there what happens, the pressure, effect of that pressure becomes more and more impact for such solutions, right? So that we will learn in the solubility of gas in liquid. So gas in liquid, so from that we have to go for the effect of pressure is very important. From that we can so derive the what, Henry law and Raoult's law. These are the very so important. Okay, so just note it down for the time being regarding that solubility of solid in liquid.